Welcome. In this video, we'll explore how a brute force attack works on pins using Python. But first, let me tell you what is brute force attack. So, a brute force attack is a trial and error method used to guess a password, pin, or encryption key. This method systematically tries all possible combinations until it finds the correct one. While simple, brute force can be time consuming depending on the complexity of the password. Now, let's dive into our Python script that demonstrate this process. First, we import necessary libraries like time used for measuring execution time and then random used to shuffle the permutations for randomness and then iter tools for mutations to generate all possible orderings of a given sequence. Next is generate combinations. This function calculates how many possible pins exist for a given length. It also measures the time taken to compute the combinations. Next is generate permutations. So this function generates all possible unique permutations of a given pin. The permutations are shuffled for randomness and then it prints the first 10 permutations and the time taken. Next is create custom pin. This is for user input. So the user is asked to select a pin length for a predefined list. The choices are displayed in a numbered menu. Then this also ensure the user enters a valid selection, a number between 1 and 5 or 0 to exit. Then, if the input is invalid, the user is prompt again. While true, the user enters a pin with the selected length. Then, the input is validated to ensure it's a numeric pin with the correct number of digits. Then, this function display the chosen pin.
So we will come now to brute force simulation code breakdown. So let's start with the brute force simulation function, which simulates a brute force attack by trying all possible pin combination with where it starts with the start time, where it captures the current time to calculate the total time taken. We also have loop under the brute force simulation where it goes through all pin combination from 0 to the maximum number for the given pin length. We also have output, prints each attempted pin. Okay? Then we have also sleep, introduces a small delay like 0.5 seconds between attempts. We also have end time rather. It captures the time after the simulation ends and prints the total duration. So second is the pin length validation. The program asks the users to enter a valid pin length ranging from 2, 5, 7, 9, 10. It also checks if the length is a valid number from the list and ensures it's within the allowed range. We have also the get underscore pin underscore input function, which it also prompts the user to input a pin for the specified length. It also ensures the entered pin has the correct length. Also, we have main execution, where once a valid pin length is chosen, it calls get underscore pin underscore input to get user's pin. Then it runs the brute force simulation function to simulate the brute force attack rather.
We enter a 2-digit pin and the script will start a brute force attack, testing pins from 0 to 99. Each attempt is printed to show the guessing process. If match is found, it prints pin 99 crack in 100 attempts, and it will also show the time taken to crack the pin. Here we enter a 5-digit pin and the script will start a brute force attack testing pins 100,000 possible combination. Each attempt is printed to show the guessing process. If match is found, it will print the attempt to crack the pin and the time taken to crack it. We enter a 7-digit pin and the script will start a brute force attack. Testing pins of 7 digits has a million possible combinations. Each attempt is printed to show the guessing process. If match is found, it will print how many attempts it takes to crack the pin, and it will also print the time taken to crack the pin combination.
We're testing how easily pins can be cracked using a brute force approach. Our program lets user input pins of varying lengths and then attempts to break them. The program systematically tries every possible pin combination. First, it calculates the total number of combinations, then generates the last 10 possible pins, and shuffles possible permutations. Finally, it runs a brute force attack trying each number until the correct pin is found. Let's look at 9-digit pin. The total number of possible outcomes. The total number of possible combinations is 10 to the power of 9, a huge number. The program goes through all of these combinations and gives the time it takes to crack it. This shows how time-consuming brute force is for longer pins. Now, a 10-digit pin. The combinations jump to 10 billion. Notice the significantly longer time it takes to crack. This demonstrates the exponential increase in difficulty as the pin length grows. We can see that adding just one digit adds a magnitude of order of time needed to crack the pin. The program also measures the time taken for each step, showing the efficiency of the brute force attack. We can test multiple pins to see how the length affects cracking time. This test demonstrates the practicality and limitation of brute force attacks, highlighting how longer pins provide much stronger security. Thank you.